So in this tutorial, I'm going to solve problems from section 14.6, which is basically about triple integrals and Cartesian. So this question is saying evaluate the integral over the region B of the function f dv. So the function f is given as this, and b, which is x, y, z, and x is between 0 and 2, y is between -1 and 1, z is between 0 and 3. So it's saying that you have to do it with this order, starting by z, then y, then x. So integrate with respect to z, then with respect to y, then with respect to x. This is also equivalent to saying using the z simple, because the first one you can integrate with respect to as your simple, then the second one that you integrate with respect to is your subsimple. So in this case, this is y, subsimple. So that means that we have a function like that, and dv, the volume, is basically dx by dx, dy, dz. And this is how the integral is going to be set like. The limits of integral, I just got it from here. Just also remember that we don't care much here because it's all constants and it's pretty easy, simple example just to start with. So we have the limits and we have the function here and dz, dy, dx, and remember the red brackets, I just put them here because we only integrate in this area and we're integrating with respect to z. So we are considering x and y as constants. So let's first do those integrals, and the integral with respect to z is going to equal to this. And then you're going to substitute your limits, so 3 and 0 for z. So I'd also like to keep the z equal or y equal, so it's clear, because people will come here and will, by mistake, you will substitute y. Just try to keep those here and that will go good. So just evaluate here. You will end up with this. Now we have a new integral with respect to y here. So we do the integral 3xy squared plus 9y, straightforward. You get this expression here, and then substitute the limits of y equal -1 to y equal 1. Substitute your limits, you get a new integral. It will take you a little bit of time to simplify this. Put 1 and you will see how stuff are going to go together. So this expression here, because -1 squared, and then because you have the upper limit minus after substituting the lower limit, so it's going to be, those terms are going to go away together, and this term is going to be the same term, so you'll end up with 2x. You just do the math and it will be straightforward, and then integrate normal integral just with respect to x. Pretty straightforward. You get this answer. So this was just a straightforward example to show you how to do triple integrals, which is basically the same as double integrals. Now let's move to a new example. The example say, okay, evaluate the integral over the region t, and then the function that we have is only x, and then dv. So it says where t is the region bounded by the planes x equals 0, y equals 0, z equals 0, and the plane x plus y plus z equal 1. So it might be a little bit hard to visualize it, but for most of the Cartesian 3D, it's easy. I'll show you here. I could have just got a nice graph of it, but I just did it myself in Paint actually to just show you how I would do it on a paper. So I will start by having my x, y, and z, right? And because we have the plane x equals 0, that means we have this plane here, right? Like the zy plane, and the plane where y is equal to 0 is the zx plane, and the plane where z is equal to 0 is actually this plane, the xy plane. So now we have our planes, just imagine they're there. We now need to visualize x plus y plus z equals 0. So the easiest way is always to sub two values. So when you sub x equals 0, so when you sub x equals 0 and y equals 0 and the function, you will get the value of z where x and y are equal to 0. And when x and y are equal to 0, that means we are on the z axis. So if I have z equal 1, then I just get this point. And then I also do the same for x. I substitute y equals 0, z equals 0, I get x equal 1. So the point, another point is given, and then doing the third substitution and get the third point. And once you have 3 points, you can just construct a plane. So just connect those 3 points together. Once you have them connected, this is a plane. So basically now, this plane here that you constructed is the plane that we want the area between this plane and the other three planes. So it's basically the corner there until you reach this triangle-like shape, which is just a part of our plane. So this is how would you like visualize it, because you need to actually know this, because to specify your limits of integrals. So now let's use a z simple y. Let's solve the question actually. So let's use a z simple y simple method. So we will start by z first. Okay. So z is going to go between 0 and 1 minus x minus y. How did I get this? Just from this equation here. Z is equal to 1 minus x minus y. Because we started by it, we just find it from the equation here. And then, because x is going to, remember also z is going to go from 0, from this plane here. Let's just get the graph. So remember that so z is equal to 0 is this plane here. So we have from z equal to 0, z is going to go from here until any value of z on this plane, right? So any value of z on this plane is the value as you just simplify for z, so z is equal to 1 minus x minus y. Then the next step, after you do that, you start by, now we did z simple, we want to start by y subsimple. So y subsimple, you have to sketch the region. So we got z simple, right? So now you sketch the projection of the region on the xy plane, because we already got the z, we got it out of the way. So now we are working only on x and y. So we just look at the projection of the region on x and y plane. So this is the projection of the region on xy plane. And if you can visualize how this became this way, how the projection is this way, just go back to the video where I showed how the area looks like, and just look at y and x and see how this works. So this is my region, and as I'm doing y subsimple, so I want to define. Well, actually, you can even draw the rectangle we draw before in another video. You can draw the rectangle here. You can say, oh, I'm starting, or I used an arrow here, so we're starting from y equals 0, which is this line. This line is defined by y equals 0, and this line is defined by y equal 1 minus x. You should know how to find y equal 1 minus x, but also there is a hack for it, because you are on the z plane, right? You are on the xy plane, so that means z is equal to 0. So if you substitute z equal to 0 and this equation here, and then simplify for y, you will end up with y is equal to 1 minus x, which is basically the same equation as the one here. So you have y equal 1 minus x, those are the limits in x and y, and then the limits in x will be simply from x equals 0 here to x equal 1. And also, if you just want to do it like shortcut, just go back to your equation here, substitute y equals 0, z equals 0, you will end up with x equal to 1. But you need to be careful when you're doing that, which equation, because it's not always as simple as that. So now we find also that, okay, y is between this and that, and x is between this and that. Now we have our limits of integration, and we know that we want the inner integration to be z, because we are using z simple, and the next integration will be y, because we're using y subsimple. And remember that in Cartesian, just dv is equal to dx, dy, dz. Substitute that in. So just to see from where I get this, so we have here the triple integral. We did not know the limits, so we just substituted the limits that we found, and we substituted for dv with dx, dy, dz. So here we go. So we have x, dz, dy, dx. And also realize that our function here is x. And you realize that I did z subsimple and y, z simple and y subsimple, and x left it to the end. There was a reason for that, because if I started by x, I will integrate with respect to x first, so I will end up with x squared over 2, and I will have like some ugly term that's gonna go inside the x squared. So I'll start seeing like bigger terms from the beginning, but it's not like you can do it in the end. It's not like impossible to do. So let's just evaluate this integral. So integrate with respect to z first. You will end up with zx for sure, and then you substitute the limits of the integral. So 1 minus y minus x and z equals 0. You will end up with 1 minus y minus x multiplied by x, and then when you do the math, you will end up with x minus xy minus x squared multiplied by dy, and also again my red brackets. Now I'm integrating with respect to y. So this integral will be integrate with respect to y. You will have y here and probably over 2 here. Just do the integral and then substitute your limits of integration. Okay, so once you substitute your limits of integration, you will end up with this expression here. It looks ugly, but it's going to be straightforward. Just do it with pen and paper. Then after that, you can simplify this expression. Actually, if you took some time to simplify it, we'll simplify to this expression here. Once you have this expression now, you just integrate with respect to x. It's just an easy question. You just I did like simplify it more, so made it x to the power of 3 minus 2x squared plus x, integrate with respect to x, and then substitute your limits. You will end up with 1 over 24. It's straightforward. All of this is Calc 1. I did not skip it, but it is just Calc 1. I did not want to spend more time on it.